Hello and welcome back. I'm Tom, and in this video we're going to be taking a closer look at how we did the install of our ultimate solar electrical system on our RV. Now, if you haven't seen the first video in this series, I highly recommend watching it because it's going to give a higher level overview of the system and the components that we installed. Whereas in this video, we're going to take a closer look at how we did the install and talk a little bit more about system design. Now, we did that install back in Florida, so let's head back and start from the beginning. We've been planning out and working on getting ready to do this project for over a month, and we put a schematic together of what we're going to be building. I always recommend drawing out a schematic for what you plan to install, as it's really going to help you get an idea and figure out space and weight characteristics of an entire system. In addition, it's going to help you keep track of all the parts and pieces you need and make sure that you're designing a safe system. If you're curious to get access to our schematic of this system, it will be available over on our website on the accompanying article. So we've got all the parts and pieces. The first thing that we need to do is disassemble the old system. With all the components in hand, we started off on the roof, disassembling the old solar system. These panels had been on the roof almost 3 years and were screwed down with over 100 screws. While they never leaked, we were glad to be removing so many potential leak points. Installing these large glass panels on the roof was a challenge to begin with due to the size and weight, and removing them was just as tricky. Once the panels were off the roof, the mounting brackets were removed, along with a TV antenna we no longer used. This was to give us as much roof space as possible to max out surface area for the new solar panels. A roof rail along the back of the RV was also removed, as the new panels sit so low that this could cause shading issues. With the roof cleared off, we sealed up all the holes with Dicor and Eternabond and painted damaged portions of the roof with a new elastomer coating. The roof was then scrubbed clean multiple times and allowed to dry adequately, as the new panels needed as clean a roof as possible to stick down to. After getting the roof cleared off, we first prepared to pull new wires for the panels. We had done a roof layout using a drone to take pictures of the roof and create a scaled mock-up to figure out where the new panels were going to go and what sizes to use, as there are multiple options available. We decided to break the panel wiring into 3 separate sections on 3 separate charge controllers. Because of this, we were pulling 2 new power leads using 6-gauge cable and would reuse the existing parallel 10-gauge cable for the smallest panel set. After removing the old junction box, we prepared to install the new wires in a conduit. So we're now ready to install the junction box on the roof, and we've removed the old junction box to put our new ones in its place. Now, if you're going to be drilling into a roof, and this is really any roof, even a house, you really got to figure out what's in the ceiling before just drilling up in there. It's a terrible idea to just go for it because you could hit all kinds of things. If you have plans for the RV or house, that might help, but if you can actually get a borescope up in there somehow, maybe drill a little tiny hole if you can't do it any other way, and look around, make sure you're not going to hit anything. In our case, we have an air conditioning duct here that we're able to get up in and look around, and we could see where the original wires went. And for this install, because we're going to be pulling a lot more wires, we're going to be installing a piece of conduit. This is just a small piece of PVC. We're going to put a long chunk in. Our roof is about that thick. A lot of RV roofs are thinner, but our roof's about that thick, and the conduit's going to go up from in here all the way to the roof. So it's going to be a lot easier to pull the wires through that PVC than directly through the roofing materials. Now, we know that we're not going to be hitting any wires or any pipes or anything because we've already drilled this hole and looked around up there, but we do have to go through our air conditioning duct, which isn't exactly ideal. But because we're going to be putting this conduit in, we're going to make sure that it's a really nice tight seal around the insulation materials in the conduit here so that we don't leak air conditioning into our attic. We're going to be using this long bit to make sure that we pilot a very straight hole, and then we're going to drill a big bore hole through with this 1 1/4 inch hole saw, hole drill, and we're just going to drill up following this hole from the bottom and then down from the top and try to line them up the best that we can. Yeah, it looks like it goes pretty straight through. We decided to use a dedicated low-profile solar combiner box on the roof that already had 2 independent bus bars for separate charge controllers. We made a slight modification of the junction box, splitting one of the bus bars to allow us 3 separate circuits. We installed the junction box on the roof, wiring our leads that would run down to the batteries to each bus bar that we would later connect the solar panels to. At this point, the roof was ready for the new solar installation. But we wanted to have the battery system installed before we wired up the new panels, so we shifted our focus to the basement. So like preparing the roof, we also have to prepare the area where the batteries and electronics are going to go. We're here in the basement of our RV where we have our existing inverter already installed. This central vac unit we really hardly ever use. So we're going to remove this, move some gas lines around, move some ventilation, and make this better suited for installing the electrical system that we put a higher priority on than the central vac. So now that we got the basement cleared out and ready for the batteries and inverter, the next thing we're going to be doing is moving the transfer switch down here and upsizing some of the wire sizing. I like to install a switch like this in my installations to allow for bypass of the inverter should it ever be required. We also use this transfer switch to jumper 2 legs of the split phase electrical system of the coach to single phase so that our inverter can power the entire rig. With the larger inverter we will be installing, it also has the capability to exceed 50 amps output because it is a hybrid inverter. This means that it can add AC power from the solar or batteries to the shore supply, so that if we exceeded the 50 amp service on a single leg, the inverter could make up the excess. Because of this, we upsized all the wiring between the inverter and distribution panel to 6-gauge wire. So now that we have the solar panels off the roof and this basement area cleaned up a bit, we're going to get to work on the heart of the system, which is mounting the batteries. We took the solar panels off first because we are going to reuse their mounting hardware to help us mount these batteries. And what's unique about lithium batteries in general is that because they don't have any acid in them that needs to sit in basically like a bucket, like a lead acid battery has like a bucket of acid and it has to stay upright. These batteries can be mounted in any direction. They can be on their side, they can be upright, or in our case, we're actually going to be mounting them upside down. This area up here is where our black tank used to be located in this RV, but a couple years ago we replaced our conventional toilet with a composting toilet. We did a video all about that, and I think we might have even mentioned that we were thinking that we might utilize where that black tank used to be for some batteries in the future, and now we're going to be doing this finally. We are going to be utilizing this aluminum bracketing, supporting these batteries upside down, and putting them where the black tank used to be. We built custom aluminum racks for the batteries to be supported on, upside down, and notched out areas where the terminals were so that electrical connections could be made. We also insulated the aluminum near the battery terminals so that accidental grounding of the system would be minimized. Getting the batteries hung up was a bit of a dance, trying to lift and support them in a space that was too small for more than one person to work, and at times I wasn't sure they would all fit. But with persistence we got them all installed, and it was time to move on to removing the old inverter and preparing the area underneath the batteries for all the electronics. We installed a wooden backing board to mount the equipment to, and the space was finally looking ready to start wiring.
So while Tom is finishing the space for the inverter and the charge controllers and bus bars, I am working on the cable busing between the batteries. These little guys will go in between 2 12-volt batteries, connect them, and turn it into a 24-volt system.
We wired the system in a 24-volt configuration. Our previous setup was 24 volts, so this was not a change for us. And we decided to stick with 24 volts because with the amount of solar that we were installing, this is about the lowest voltage we would want to run because it halves the current over a 12-volt setup, allowing us to use smaller wires, less charge controllers, and enjoy higher efficiencies overall. We wired the batteries using a combination of 1-gauge, 1-aught, and 4-aught cable depending on where the cables were installed, as current is cumulative in a battery pack. And by calculating the expected currents, we were able to work with smaller gauge cables in some tight spaces. Next, we moved on to installing the primary electrical components and wiring that would mainly be installed underneath the upside-down batteries. I always use busbars in my installations to distribute power, so we first figured out where to install the busbars and how to wire them to the batteries. The positive battery lead first passes through a fuse to protect the system from shorts and overcurrent situations, and the negative passes first through a master switch, then through the system shunt. The shunt measures all of the current into and out of the batteries to give our BMV712 battery monitor that we already have installed a very accurate reading of the battery's state of charge. We then installed our 3 solar charge controllers. We are utilizing Victron 50 amp MPPT units that can accept up to 100 volts from the solar panels. The charge controllers require fuses between them and the batteries, as well as disconnects between them and the solar panels. Now that we've got the batteries and the bus bars installed, the next order of business is installing the inverter. Now this is the biggest, heaviest piece of electrical equipment we're installing. It's basically a generator between the batteries and the AC system. This 5,000 volt amp unit weighs 66 pounds, so it's a little tricky to move around, but we already test fit it. We know where it's going to go. We just need to build the brackets, secure it in place, and hook it up. Because this inverter is so large, the Battleborn batteries require an additional piece of equipment installed on the negative lead called a CSL, or current surge limiter. We decided to put the negative there because I created this little 90-degree bend that is going to connect to the bus bar onto this unit, which is the CSL. Now the CSL is a unique unit that is required for very large inverters in the Battleborn system. This 5,000 volt amp inverter has large capacitors in it that they charge so quickly that it'll basically trick the batteries into thinking there's a short in the system and they will shut off. So this is basically an external piece of BMS that is only required for these large inverter systems. So we're going to install this here. This is basically the negative lead which will go into the inverter, and hence the big blank space right here is where the inverter will be installed. The inverter hooks up to the positive and negative bus bars to pull power from the batteries and solar system. With the inverter hooked up to the batteries, the AC side needed to be wired to the transfer switch on both the input and output power leads. Before firing the power system up, we first had to transfer our DC supply over from the Tesla battery. While the Battleborns and the Tesla battery are both lithium-ion batteries, they differ in their chemistry and build. While they both consist of many smaller cells internally, the Tesla cells are known as NCA, or lithium nickel cobalt aluminum, whereas the Battleborn cells are known as LFP, or lithium iron phosphate. The Tesla is much more energy dense and lighter for the amount of power that it contains. However, it's much more prone to catching fire if something goes wrong in the system. The Battleborns, on the other hand, are a very stable chemistry and have additional battery protections built into every battery. We had the privilege of building a few of these batteries that we're installing for the Go North expedition and are confident that they're a safe design and will last a very long time.
And then what?
Here it goes. It's kind of sad and also exciting at the same time, but I'm going to pull this little wire right here, and the Tesla system is going down. It is officially disabled. I'm going to remove our 24 volt converter, move it over onto the other system, and then we're going to fire that sucker up and program it. Most RVs and their DC appliances run off 12 volt power. Because this battery bank is 24 volts, we need to convert it down to 12 volts for the smaller DC loads of the RV that require it. We do this with a 24 to 12 volt DC to DC converter that we are reusing. So the system is almost done. I'm super pleased with how it's coming out. The last piece to install is the comms, the brains of the operation. The Octo GX is going to connect to all 3 charge controllers. It's going to talk to the battery meter that we installed inside, which talks to this shunt right here. And it's also going to plug into the inverter via this Ethernet type cable. So the Octo GX, we're just going to install right here, plug everything in, and now we're going to check it out. With everything installed and connected, it was time to check out the system and turn it on. Well, the system is now finished up and we're about ready to energize it. Before we do that, however, we're going to do a safety checkout procedure and make sure that everything is wired like it should be. Even though I think that I've wired it up properly, it's pretty easy to make a mistake. So what we're first going to do is we're going to put our meter into a continuity mode where it beeps when we actually touch the probes together. In this mode, we're first going to go ahead and make sure that things that are supposed to be connected together are connected together, like our negative bus bar to the back side of the negative switch, which is going to switch on and off the entire system. It beeps, so it's connected. We're also going to check to make sure things aren't connected that shouldn't be connected, like the positive to negative bus bar. If that beeped, we would have a serious problem. I've already gone through and tested everything out, and it all looks good. We've also gone through and tightened every single lug, made sure that every single nut was tight. Those are also easy to miss. The next thing we're going to do here is actually throw the switch and light up the bus bars. Once we do that, we're going to go ahead and first of all make sure that smoke doesn't come out of anything, and then we're going to go through and we're going to test the voltage and make sure the voltage is going to the appropriate appliances in here before we turn anything on. Although these three are going to come on automatically, and we should light up our 12-volt system with our converter when we throw this switch. So let's do it. Moment, no return. Well, that was anticlimactic, but that's exactly what we want here in an electrical system startup. Nothing blew up, nothing has smoked yet. I can hear these things kind of whining a little bit, so they've all turned on. You can see them all flashing, so that means they've got power. We made sure that the inverter was switched off before we powered everything up. I'm gonna go ahead and just make some quick tests here on the bus bars, make sure that we have the appropriate voltage, 26.5 volts, so the batteries could use a little bit of a charge. We don't have AC to the inverter yet. We've got our main switch off, but we can go ahead and we're gonna flick on this inverter. And the inverter's come on. It looks like it's throwing an error code. The next thing with the inverter that we need to do is program it.
Programming the inverter was done with a converter and special Victron software. The inverter needs to be programmed to the proper charging characteristics for the batteries it's connected to. After being programmed, it was hooked up to the Octo GX unit and then brought online. This is done using a Victron app on a mobile device to connect to the GX's Wi-Fi network, and then run a special remote access control panel on the phone. From here, we connected it to our local Wi-Fi network so that it could be accessed from the network and upload its data to the Victron VRM portal, where we can monitor and control the system from anywhere in the world.
I got some brand new solar panels to put on this roof.
We're installing the BB230A and B series panels. They are rated at 230 watts and come in two different sizes, a long and skinny or wider version. They also come in two colors, a white trim and a black trim, and we are testing both out. Getting them onto the roof was very easy as they only weighed 12 pounds apiece. We first laid them out in their approximate configuration and marked their positions on the roof. We then cleaned the roof again with a 3M adhesion promoter, but isopropyl alcohol works as well. It's just critical to get any dirt and oils off the surface for the panels to properly adhere to. We held the panel in approximate place and removed the adhesive backing, first sticking down one edge on our marks. The longer panels included a separate adhesive type at one end that can stick down to hold the panel in place while the main adhesive backing is removed. The panels are then slowly lowered to the roof, making sure all air escapes from underneath them. Once on the roof, firm pressure needs to be applied to the panels, and we did this using a towel to distribute our weight while pressing over the entire surface area. While these panels are very lightweight, the biggest drawback we see to them against their glass counterpart is heat dissipation. Hotter solar panels perform worse, and being dark color and stick down, they also could dissipate heat into the RV's roof, which might heat up the interior more. Because of this, we're doing a test with a few of the panels, first installing the adhesive portion on a corrugated plastic backing board that we got from our local home improvement store. We stuck the panels to the backing, then installed the whole assembly to the roof, with the hope that the air gap in the corrugated plastic might help keep the panels cooler and prevent roof heat dissipation. We applied die-core sealant to the back of the solar panel unit and utilized a Turnabond tape to seal down the edges to the roof. While not necessary, we also decided to use 3M Extreme Seal tape around all of the panels. This will help keep debris and water from settling up against the panel's sealant and give the installation a cleaner look overall. With the flexibility of these panels, we figured that even the curved surface of the front of our fifth wheel's cap was fair game for panel installation. Installing panels here is not ideal for performance, but this is our ultimate dream system, so we're maxing out all available surface area, and we'll keep track of their performance compared to the rooftop install. The last lower panel on the front of the RV did pose a bit of a challenge because the surface is curved in two directions. This caused a small bubble in the center of the panel that we could not get out once stuck down. Because of this, we would recommend avoiding large stick-down panels on rounded or surfaces with two curved directions, and should have chosen to use multiple smaller panels in this location to avoid this. We wired the panels in a series parallel configuration, with 2 panels in series and the rest in parallel. Because the front cap panels would perform so differently and experience much more shade, they had to be on their own solar charge controller to avoid impacting the performance of the top panels. The front set of black solar panels were also put on their own charge controller, along with the largest set along the back of the RV.
Well, we're back in the basement for hopefully the last time. We're about to fire up the solar charge controllers. Now, before we do this, we need to make sure that we go into the Bluetooth app and select each charge controller and program it for the appropriate charge profiles of the batteries. Once we've got everything programmed, what we're going to do is we're just going to make sure that our voltage is coming down from the roof appropriately. We connected everything with the disconnects open down here, so it didn't fire anything up when the panels were first connected. It's important to have a disconnect in the system because you never want to make a connection to the solar panels under load, either in the bus bars or on the MC connectors on the roof. So there's no load in the system, but we're going to go ahead and put our voltage meter into voltage here, and 53.8. All right, so we're seeing the right numbers. So that means that our voltage is coming down properly. Now all we have to do is just close these switches, and hopefully this should go into a bulk charge state after it's sensed the power coming in. And there we go, it's reading the bulk. So now we can go in here and we can go ahead and get in our app. You can tell that you've connected to the appropriate one as it will blink all the lights at the same time, and there we go. It's a nice heavy cloud day, so we're seeing 199, 240, so it's starting to charge. It's showing that it's charging. We're gonna go ahead and close the rest of these because it seems like everything's working out appropriately, and we've got solar power.
With the system fired up and everything working properly, it was time to put it to a road test. One of our biggest limitations with a solar setup on our RV was weight, and even though the batteries and inverter are heavier than our previous setup, and we have substantially more solar, we calculated that we only gained around 150 pounds over the previous setup, well within our 200-pound goal. We drove north for the summer to escape the Florida heat and head to our off-grid property in Michigan, where this system would truly be put to the test.
We've been living off-grid all summer long, and the system has been making all of our power needs and has been performing great. We've been collecting lots of data about its performance and also comparing it to the old solar panels. We kept the old monosilicon solar panels and built a ground-based array so that we can compare their performance against the battle-born solar panels on top of the RV. We've received a lot of questions about this system, and we're going to be working on answering those on articles on our website and in future videos. So you're going to want to head over to our website, link in the description below, and sign up for our newsletter so that we can notify you when we release our findings. We're going to be answering questions like, what about the heat dissipation of the flexible solar panels, and does it impact performance? How are those front solar panels performing, and how does it perform in different weather conditions and temperatures, like in the winter cold or the low sun angle? Now, we are still collecting all this system data, so in our next video, we're excited to share why we installed so much extra solar power and how we're using it. As always, thank you so much for joining us, and we'll see you next time.